Okay, welcome everybody in lesson 5. Here we are, and now I'm looking at the this little um, voice chat thingy, the the text from the chat log that we have, right? Because last time you guys were just typing here, and I didn't notice at all. Yeah, you've been using this since like the second lesson, and I've never noticed. So like I wasn't ignoring you. I was just simply unaware. Okay. So what are we doing today? Let me open up Paint and just kind of do all this thing in this video. Okay. We have a lot to go through, and this lesson is going to be pretty interesting, actually. It will have a lot of, it will use a lot of things we've already learned in a practical format. Okay, let me open this back up because I'm gonna forget it. And then I'll just try to remember to like look here every time we finish a topic or something. Okay. Gonna get my drawing pad here. Oh, and also I've noticed that the YouTube channel is actually picking up some attention, which is pretty weird because I didn't expect that. But like, I'm not even putting these videos anywhere, and like uh, the lesson of last week got almost 100 views, which is like pretty weird. So I guess YouTube is in our favor now. Okay. I'm gonna open up this one. I think I have something else open here, a different scene. Yeah. Okay. Don't worry, I'm just sometimes putting stuff here. Okay. Yeah, this was what we were working with the last time. Yeah, Godot is trending, that is definitely true, but to be honest, I didn't expect it to like actually like pick up views because I think Godot blew up after the Unity files, but that happened like 2 weeks ago, right? So I think these two videos were also out, and I was promoting them, and like, yeah, maybe this is the right time to just do more promotions. Okay, so what is our lesson called now? The structure of levels and resources and loading, loading whatever. Yeah, and loading and recursion, state machines, delays. Okay, that's just a lot. And like these subtopics already incorporate those. So okay, we're gonna go one by one as usual, and yeah, we'll also look at these in Godot. So setup of a multi-scene scenario. What does that mean, right? So you can just imagine that anywhere basically in any game, like you are in a level and then you just load into another level, right? For example, in like Super Mario Brothers or something, I have no clue. You just you're just in level 1 and then you complete it. You go to level 1 2, and you know every time the level scene gets swapped. So like the level scene always becomes whatever we make it out to be. Um, in a lot of games, the main menu is also its own scene or its own level, and then you just open up whatever level you were playing on, right? If you've played the game before, and if you have not, you open the first level. So how does it happen in Godot, right? Actually, it is quite transparent. So basically, um, let me show you. If you launch this scene, right? This is our level now. You could say that, but if you navigate to the scene tab and go to the remote, you will see there are other things here. So here's the root. Of course, it's the tree root, the root of everything. And oh wait, yeah, I knew it. Sorry, sorry guys, it happened again. I was not sharing my screen. Okay, so I mean, I wasn't really drawing anything, and then I opened up Godot and I just knew that I was missing something. Okay, so I'm gonna show it again. Okay, so the YouTube viewers are loving this, I'm pretty sure. Uh, so if you run the current scene, basically this is our current level now. You could say that. This is our current level, right? And if you navigate to the remote tab inside scene, the scene panel, you will see we have the root, which is like the top of everything, because remember that scenes are set up in a tree structure. We've talked about that in the previous lessons. And we not only have the current level, but also our singletons. And actually, I could spawn objects here as well below root, and like they would still be valid. So this proves the fact that the current scene is just another node you have spawned, basically. It's no different from anything else in the scene tree, right? So if we want to load another level, I'm going to just, actually to begin with, I'm gonna rename this. I will call it level 1. And also rename the root node. And then create a copy, level 2. Of this one, and I just type this is level 2. Let me close these. And here, this is level 1. Okay, so how do we load a new level, right? I'm gonna attach a script to level 1. Actually, let's do it on the game manager, right? We have the game manager as a singleton or an autoload set up here, and I typically prefer putting scene load functions on autoloads because that way, like when you're loading a scene, you know, the previous scene gets deleted eventually, and like that can lead to some trouble. So a scalar function load level. So we will need the level as a parameter, and there are two ways to do this. We could either assign the actual resource, or we could just say we could just input the resources path, which you can access, by the way, by right click and copy path, and then we have it just like that. So I'm going to do that because that's just simpler. Level path, and this is going to be a string. So in the get tree is basically you can see this returns the scene tree that contains this node, and scene tree essentially that's just the you can see it writes it here. Manages the game loop via a hierarchy of nodes. And I think, yeah, we will need to access root, which is actually just what we saw here, right? It is this one. This is what we're accessing here, and we should have a change scene method. Change scene to 5. Oh, okay. I think this is new in 4.1. Anyways, so use get tree to like get the scene tree, which manages the node hierarchy, and then it has a method called change scene to 5. Let's see what happens if we call this. For example, we could call it on the press of the, I don't know. Oh yeah, hang on. We're going to call it when we press the open level key, which is gonna be E. I'm gonna leave it on physical because why not? And you can think about how you would handle this. I'm gonna also jump into it. I will put this into input. It could be fine in protest as well. If is action just pressed, open level, and then we will do game manager dot load level. And there we go. You can see that the text changed and that I did not change the text. This is actually the scene getting loaded. You can see now it's level 2 that we have. And yeah, right now it's level 1 and it becomes level 2. Okay. So how does Godot handle this? Well, when you start the game, Godot will know what scene you're basically playing from. And so we have get tree dot current scene, right? And that's basically the scene we're playing from. I can also show you, for example, by like printing its name. Yeah, level 1. There we go. And if I just want to print it here, it is still level 1. And it has an interesting reason. So loading a resource takes a while, right? It doesn't happen in an instant. You can see. So we could actually, I think we saw it in remote. So if I press E, it takes a bit for the actual node modification to show up here. So we would need to do something called threading, or we could I believe we could also wait until until the resource is loaded. There's a thing called a resource loader, and we're gonna cover something like that when we talk about the wait. So let's just do this as it is for now and move on to instantiating preload and the load function. So as I told you, there are two ways to handle this, and one is passing the input string, the level path, And another way to do it is we could actually do it manually without this function. So yeah, I'm still gonna keep this. The method is pretty much gonna be the same, but I think this is also valid in Godot 4. So I'm gonna do this. We are using this load function to load a resource at this path we assign, and then we create an instance of that. Oh yeah, this is just not how it goes in Godot 4 anymore, I guess. Okay, that's a shame. I was hoping I could show you that way, but oh well. Okay, I reverted these to work with this one. But yeah, technically you could just do that where you basically spawn an instance of the scene and assign it to the current scene. Wait, actually, I may know what was wrong. So let's put this into a variable, right? We'll load the level path and then create an instance. And I'm thinking we need to add it as a child of the root. Yeah, there we go. Now, however, level 1 is still here. And why? It is because we actually never really delete level 1. Because, you know, we reassign the current scene, but regardless of that, so we won't refer to this as current scene anymore, but it still exists. So we would need to destroy this object, and every node has this method called queue_free, which basically destroys it. Let me show you. See? And this is actually even faster than doing this built-in method. You could see it pretty much changed much faster to level 2. At least I think there was a slight difference. So yes, this load function is to load resources which are stored on the hard drive, right, in the file system. And this is pretty important. So make sure to remember this. Because if I just want to spawn any scenes or any objects, we will need to use load. If we have the resource path in our hand. And if not, then we will also look into that. But this is what this is basically the implementation of this function in simple terms. So we load the level, create an instance of it, destroy the current scene, spawn the new level instance, right? So that it's in the scene tree. Because otherwise, if we don't add it as a child, it is an orphan. That's how it's actually a bit of a funny name, but that's actually how we call nodes without parents. And if it has no parent, it's just, you know, not in the scene tree. So we do that, and then we assign current scene to be the level. Because remember, this just stores a reference to whatever we give it. Okay. A common practice to increase runtime performance is to load resources at the start of the game. And we can do that by using the preload function. So if I want to say level 2 preload, and then we will need to know the path, right? And then we instantiate. So preload, basically, if you look at it by holding Control and then left click, it takes you here. So basically, with this, so when does this get executed? It gets executed when the game starts. So effectively right now. And that means we don't need to wait for loading here, but in the case of levels, this is a bit problematic because if you have like 100 levels, starting your game will take forever. So in that case, it's just better to whip up a loading screen and do the loading on spot. Yeah, yeah, exactly. Exactly. This is how loading screens are created. So the way we've just done it in a game, uh, we used a black rectangle and then made that gradual visible, so it kind of faded in, and when that happened, the other levels started loading, and we started carrying through data, right, and just saving and all that stuff. And once the level loaded, we transferred the data we could, like the player position whatsoever, and then we made the black rectangle disappear after that. So yeah, this is a really good way to describe it. Okay. Oh yeah, right. And now I should be able to do this, right? There we go. However, if this was like I don't know, an enemy, right? It would be ideal if it was only preloaded, because if I do instantiate, this already creates an instance of whatever this loads. So if I wanted to spawn enemies, right, then I would be basically putting the same instance here, and that instance may be dead already, and there just couldn't be multiple of them, because if I if I wanted to spawn an enemy, right, what would I do? I would do an add child or something, and then like set HP or something like that. But if my enemy is like created in the outside the function scope with dot instantiate, that's no good, because then you're just playing with the same instance over and over. But if you have if you only have it preloaded without instantiate, you can just create new instances all the time whenever you spawn a new enemy. I hope that makes sense. Okay, so yeah, that was spawning objects in a pattern. It means kind of something different. we can actually play around with that. This is also a good exercise. So we're gonna spawn some Godot icons because that's as far as my creativity goes. We will create a new scene. I'm just gonna maybe say simple sprite, and it will have this guy. Let's downscale a bit. Okay, and so I want to spawn 3 Godot logos one by one next to each other so that they don't overlap. You can think about how we would pull that off, and I'm gonna start that too. So first we'll need to know where we'll need to know what to spawn, and another way to do it is by dragging it here and just creating copies of this node, but they're just a bit messy, right? So we will do export Godot logo scene, and anything that's stored on the hard drive is of the type of packed scene, if it's a scene. Otherwise, it is usually a resource, but packed scene is basically anything that's .tscn. So if you drag this here, right, into the inspector using the export annotation, now we know what we want to spawn, and using loops, let's say I want to spawn 3 of these guys, we will spawn them starting here. Okay. So we need to know the offset, right? But first, I'm gonna do this, and then we'll just add it right by the root. So logo, and then we'll need to set the position. So we'll need to know the offset, right? Because it is gonna be post that position. And I'm not sure if I've showed you these guys, but using the $sign, basically you can refer to a child node. If you type its pet after the $sign, basically this is the shorthand for the get node method. These two basically do the same thing. So now if I execute this, you can only see one logo, but that's because they overlap each other. And their names kind of differ, so you can also change that so that the name equals Godot logo plus I. And we get an error. So this is quite common. This is gonna pop up a lot of times for everyone. And here, basically what it says is that we want to add a string and a integer together, which is like not possible in any sense. So we need to convert the number to a string. And there we go, 0, 1, 2. Look at that +1 to start the indexing from 1. Okay. And now we need to know the offset. So for every node, every sprite, right, if we want to spawn them, this is beautiful, like this, like next to each other. So this is gonna take no offset, right? this has to take offset once and this has to take it twice. And so I'm going to write x here, and this is what x is gonna be basically. It's the horizontal size of the sprite. So we can get that by typing hang on. Let's just do texture.get size it is, I think. And get size returns a vector. Alright. Okay, so yeah, the issue there is that we need to add the vectors together. We cannot add just a single float to a vector. There we go. Now they spawn by each other, right? They take proportional distances. However, they're not by each other directly, even though we get the offset x, right? And that's the texture's x size. So remember how I downscaled this? If I set it back to 1, see, now they are by each other, but so basically we need to take scaling into account. So this is going to be logo.scale.x. We multiply the texture size by that, and there you have it. Also, we could just set the type of this, right? So dot texture pops up, or it doesn't. Oh yeah, that's weird. I guess it can't infer the type just from a vaccine. So what I do in this case is, if I want to access a property, I just type the type name there, and then it will show the properties, because this is basically a typecast. This is how we call it, and you just type variable name as and then the type, and this just helps with autocorrect and all that stuff. Okay, so randomization is our next topic, and this is pretty interesting. Basically, if we want random numbers, you know, if I want to say I want to spawn 3, 4, or 5 nodes here, right, in this little row we have, then we have a lot of functions. So if you type in rand, which is short for random, you see a lot of things here for floats and also integers. If I do rand I range 3 to 5, I'm gonna see this will keep generating them from 3 to 5. And then there's something I like to call weight RNG. That is weight. And what that means, so in the case of normal RNG, right, if I want to spawn from 3 to 5, every number has even chances, right? So 3 has 1/3, 4 has 1/3, 5 has 1/3. However, if you create an algorithm for weight RNG, you could make it so that there's a 20% chance to spawn 3 of them, and then 70 to spawn 4, and 10 to spawn 5. And you actually already know everything to write an algorithm like that. I'm also going to show you how I implemented it in my game Area. this is pretty interesting, and I can just send you a screenshot of the algorithm and you can analyze it if you wish to. There it is. Okay, I'm gonna print screen this. I think it works the intended way. I mean, I've been using it in my game and like it works pretty well. But if you find anything else, just let me know and we'll see. So basically, this is just a for loop. And then it just keeps adding up the chances. Basically, this goes from 0 to 100. So like the percentages must add up to 100. And yeah, I just find this pretty cool. And here's this keyword called static, which we haven't seen yet, but static basically makes it so that you don't need to instantiate a class to access a function. Let me head into our project and show you there what I mean. So, as you may know, we can already access every function in Game Manager, despite it being not static. And that is because autoloads of singletons are also often called static classes. So if I create static function print this, and then if we just print this because I don't have a better idea, then for example in Game Manager or any other class, if I oops, I'm getting lost. If I type the class name, right, we will see print this, but we don't see other functions. If I type in that, and this won't actually do anything. See, we just don't have it. Print orphan nodes is a built-in. So yeah, the static keyword is also really useful. Okay. So that's randomization. We have now state machines and the enums. And basically, state machines are used for a lot of behaviors. So if you want to create a CPU or an enemy AI, right? It could have a lot of different behavior states. So like, it could be idle, it could be attack, it could be follow, right? And all of these would be checked using state machines, and the enum type is a common way to implement state machines. This is the syntax for enums. Wait, idle, attack, follow, right? So this is the basically the enum name, and if I type in state, you can see I have the three constants we just created here, but you can also create anonymous enums, and then you don't need a enum name. And you can also bridge this from other scripts. So I could type level 1 state dot, and then they are here again. And there are also other functions to like get all the keys, which are the idle that I can follow, and the values, which we will see now. So if I want to print state idle, what do you think we're gonna get? 0. And if I print attack, we get 1. And now if we print follow, it is obvious, but it is 2. So enums are indexed from 0. You can actually change this. You can like override the values. Now if I run this, the counter starts from 5. Okay. So this is enums for you. They make system design a lot easier to handle. And also a lot cleaner. And if you want to check for behavior, so if I create a variable called like current state and set it to state.idle at the startup. Oh yeah, you may have already figured, but enums basically, they are just integers. Like, literally when you run the game, Godot translates them to to their integer equivalents. So as I'm typing state.idle here, at the time of compilation, it becomes 0. Like the compiler literally replaces that. And then here's something really cool we haven't looked at yet, but we have this keyword called match. And basically, I'm gonna show you the way you already know it. So if you wanted to check which state we are in right now, or which state our AI has, we do if current state equals state.idle, and then do something. And to check for the other state, we do else if current state equals attack, do something else. And then it could be an else too, but I'm just gonna do it like this for now. And if current state equals follow, do some third thing. So match is basically the same thing as this, except it's a bit cleaner to read. So the syntax is like this. That's it. It is much better to read. And the else branch in a match, you could call it like that. It's underscore comma and then pass. Let me show you. I'm gonna remove idle, and so that's the only option not defined here. So let's see what happens. It prints default, and therefore that is true, as I just said. Okay. And then we're gonna talk about timeouts a bit more. I know we talked about them the last time, or before that, I don't know. Was it? Oh yeah, I think it was lesson 3. Alright, anyways, we're gonna get into a bit more convenient method of using timers and delays and all that. So let's say I want to spawn these nodes every second. So like the first one spawns, 1 second passes, and so on. So we have this keyword called await, and basically that waits for a signal to fire, and until then the function is just stopped completely. So in get3, the function we've talked about before, let's create timer method, and then we can set, you see this is time sec. If I set this to 1 and get its timeout signal, let's see what happens. Now it spawns just like that. So basically, you want to use a wait whenever you need to wait for a signal. However, I'm not sure if I want to get into that edge case. Sorry, there's just something on my mind which can be a bit finicky to deal with. At least it was, yeah, It should still be running Godot 4 because it really is about logic. So yeah, I'm gonna show you because this is pretty worthy to see. I'm gonna create a signal called done. This is how you create a signal. It's as simple as that. And then I will await it here. And we'll have a function which emits that signal. We will do task and then we emit done, right? Actually, we could do the spawning. Yeah, the spawning should be good. However, now I'm gonna make it so that we can spawn from 0 to 2. So now we have our spawner, right? And once the spawns finish, we have it done, and then we should get finished printed. There we go. It works. Okay, I'm gonna make this in the range of 0. And finish this still not printed. And if you think this through, so we enter do task. Since this is in the range of 0, we don't enter this part. So we emit the signal right away. And just after that, we start awaiting done. Which means we are waiting for done after we actually emit it. So if that can occur, I usually do get 3, but process frame. So this basically waits a frame. That's what this does. And then now you can see we get to this line properly because we need to emit the signal after we start awaiting it to be able to proceed. I hope that makes sense. I've had trouble with this a couple of times throughout my coding journey. So yeah, just a heads up. And then I have this timer node as well that I wanted to show you. It can be pretty important. I'm gonna revert this like that. And so in timer we can also configure the wait time. Oops. We can say if it's a one shot, so if it fires once, and we can say if we wanna start it as soon as it enters the scene tree, and we do. So now we can do timer dot timeout. Push of timeout is the function, signal. Yeah, there we go. Okay. So there's that. I know I mentioned also using signals for loading the level resource. I'm gonna probably just send you this. Is this is this what I used? I think so. Yeah, this is a bit convoluted. I don't know how I looked it up way back in the day. Yeah, everyone's just recommending these. Uh, oh yeah, this is something similar. If you want to, you can just read into this. I'm not saying it's necessary, but who knows? If you're interested, you can just look into it. And then I think that wraps up today's session. I'm gonna save these notes later and upload the video. I may not be able to hold a lesson next week, so I'm thinking I may just record the next session at some point and then like upload it whenever the live session is supposed to happen, because next week Thursday is my birthday, and I don't know if I'll be around, but like yeah, I'm gonna keep you guys notified. So yeah, there's that.